Nadine Chapman, the National Varroa Training and Education Coordinator. Today I'd like to give you an understanding of how bee and mite populations interact. This is important because you need to be able to relate your mite loads with what you're seeing in your hives and decide on the appropriate action to take. First, on the left, we have the honeybee seasonal phases taken from the Honeybee Health Coalition, which is a US-based group. Many parts of Australia do not have a dormant phase, but the other parts of this graph are likely to hold true. In blue, you have the bee population, which increases in the population increase phase, reaches the maximum in peak population phase, and decreases in the population decrease phase. In yellow, we have the mite population. There's a lag between the increase in the bee population and in the mite population, and the mite population hits its maximum after the bee population has started to decrease. Now, thinking about what this means, you will see in your hives on the right, in the dormant phase, if you're lucky enough to have one, there'll be no brood and all the mites will be on the adult bees. When brood is present, Varroa will be very quick to jump in and start reproducing. Most of the mites will be found in the brood, and this is because Varroa spends little time outside brood cells, between 2 and 18 days. However, more than half of mites will enter a brood cell and start reproducing within less than 3 days. During peak bee population, there's a good number of workers to brood. And still, you'll find more Varroa in brood than on adults. During bee population decrease, as the number of brood decreases, brood cells are more likely to contain multiple foundrous mites. Adults are also more likely to have multiple Varroa hitching a ride on them. There is a freely available modelling program from the US Department of Agriculture, which you can use to look at the effect of different actions you can take on mite populations. Here I've used data from Louisiana with no treatments or interventions to reduce the Varroa population. On the left, we have the bee population. Adult workers are in black and worker pupae are in purple. At the start in the blue area, you can see that the number of workers is decreasing. This is just them dying off over winter. Next, you see in the increase phase in yellow, the number of workers and worker pupae are quite similar. And then in the population maximum in red, there's a good number of workers to pupae. There's a nectar dearth in summer. The hive stops rearing brood, which results later in a drop in the worker population. When conditions improve, the worker and brood populations increase again, before decreasing as it gets closer to winter. Now, if we look at the right at what's happening in the Varroa population, we have Varroa on adults in black and on worker pupae in purple. Varroa responds to what's going on in the bee population. In that period at the start, we see them moving off the adults and into the brood. We see that the rate of increase in the population is faster in the red maximum period than it was in the yellow increase phase. During that nectar dearth, when there was a lack of brood, Varroa gets pushed onto the adults, but once brood is back, they're back to mostly being found in the brood so they can reproduce. And then there's some fluctuation going into the cooler period, as at first Varroa continues to reproduce and increase their population, even though the bees have entered the decrease phase. Something we might not think about very often is the number of mites in each brood cell. You can see that for most of the year, only about a quarter of brood cells are infested. However, as we enter the population decrease phase, this really increases. By the end of it, every brood cell can be expected to be infested with multiple mites. And this is really bad news for those workers because they will come out smaller, with smaller fat bodies, have damage to their bodies, reduced mental faculties, and increased viral loads. And these are the bees that are going to get you through winter, if you have something that can be called that, and start off your hives in spring. If most of your workers are unhealthy, it's really hard to have a healthy colony, and it may not be something they can recover from. So it's really important to take action in autumn or any time there's a reduction in brood production to make sure that you're preventing that from happening. When you're making your Varroa management decisions, you're hopefully basing them on monitoring actions via a alcohol wash, soapy water wash, or sugar shake. That's because we're in the build-up phase. Varroa numbers are highly variable, and beekeepers are finding reinfestation severe in some areas. Once that settles down, then maybe you'll be able to start treating by the calendar. But for now, how can you relate the number of mites in that wash to the number in the hive? Here we have the number of mites in the hive in red with the numbers on the left. We have the number of mites in a wash in grey and the number on the right. So looking at this point here, circled in blue, there are about 470 mites in the wash and around 14,000 in the hive. I've been told by Emily Nordyke that a hive in the US would not survive with that number of mites. So just remember that this is a model and it doesn't have any treatments or mechanical controls. The first thing you probably noticed is this peak circled in green. The number of mites in the wash increases because the workers are dying off over winter. And so Varroa has to congregate on the remaining workers. Then over most of the year, the number of mites in the wash is pretty constant, but the number in the hive is increasing exponentially. And that's because most of them are in the brood cells reproducing. Then towards the end of the season, there's less brood and Varroa is forced onto the adults, so you'll be more likely to find them in the wash. When you're relating the number of mites in the wash, you need to consider how much brood there is, and every time you do something to reduce the Varroa population, you'll be bringing that red line back down. You should be looking for evidence that your hive isn't healthy and be taking action. That may be that the bees are small, the brood pattern isn't good, the brood aren't healthy, there's wing or other deformities from being fed on, failure for the hive to thrive, and reduced production. So make sure you are monitoring regularly. During the build-up phase, while Varroa is spreading and the feral and poorly managed hives are dying, we recommend every 3 to 6 weeks, depending on your conditions. Remember, it's much better to lose 300 bees regularly than to lose a hive or all of the hives in an apiary. Make sure you're doing your monitoring consistently, with the same method and the same volume of bees. This is what you're using to make your decisions, and there are financial implications and outcome for you and your bees. And if you're making those decisions based on faulty data, you might not make the right decision.